All right, team, let's dive right in. Welcome to today's practical explainer session. If you're a junior engineer, part of the QA/QC staff, or a site supervisor, you are absolutely in the right place. Today, we're stepping right onto the construction site to master the fresh concrete slump test workflow. We're going to look at exactly how this is executed on our sites, step by step.
Here's a quick look at our agenda for today. We'll cover the risks of visual checking, what a slump test actually is, the apparatus you need, the step-by-step site procedure, the different slump types, and finally, your essential site checklist. Let's get into it. Section 1, the visual checking risk. Picture this daily site scenario. An RMC truck arrives. The contractor is in a huge hurry. Someone looks at the chute and says, hey, the concrete looks fine, let's just pour. Should you approve it? Absolutely not. An experienced site engineer never accepts concrete just by eyeballing it. Visual checking is incredibly misleading and can cause massive structural issues down the line. And here's exactly why. If the concrete is actually too dry, even if it looks somewhat manageable flowing out of the truck, you're going to face major compaction issues and a severe risk of honeycombing once you remove that formwork. On the flip side, if it's too wet, you risk segregation. That's where the coarse aggregates separate from the cement paste, leading to bleeding, major strength reduction, and terrible durability. We need actual data, not guesses. Section 2. What is a slump test? Fundamentally, this test is all about checking workability and consistency. Basically, it's the ease with which fresh concrete can be mixed, placed, compacted, and finished without segregating. Now, I really want to bust a major myth right here. The slump test does not, I repeat, does not directly measure compressive strength. Strength is checked later when you test your cast cubes. The slump test is entirely about making sure the fresh concrete is in the exact right condition to be poured properly today. Section 3. Slump cone and apparatus. All right, here is your testing toolkit. You need the slump cone, which is also known as the Abrams cone. You need a rigid, non-absorbent base plate, a tamping rod, your measuring scale, a scoop or trowel, and your site documentation, like the slump register or pour card. And please listen carefully here. That cone must be completely clean, damp, and absolutely free of any old, hardened concrete from yesterday's pour. You also need to know the exact standard dimensions. There is zero room for confusion on site. The cone is exactly 300 millimeters high, the bottom diameter is 200 millimeters, and the top is 100 millimeters. As for your tamping rod, it must be 16 millimeters in diameter and exactly 600 millimeters long. Please don't just use a random piece of cut rebar you found lying around. Use the properly calibrated tamping rod. Section 4. Step-by-step site procedure. First things first, confirm the RMC chalon details. Check the grade, the dispatch time, and your approved slump range. Next, place the cone on your rigid level base plate and hold it down firmly by standing on the footpieces. Then, take a true representative sample. This is crucial. Never just scoop the watery surface mortar from the truck, and never take segregated concrete from the corner of the chute. You have to get a mix that represents the entire batch. Now, for the strict technical execution, you have to fill the slump cone in exactly 3 equal layers. For each layer, tamp it exactly 25 times uniformly with your rod. Not 20, not 30, exactly 25 distributed evenly across the whole cross-section. For the second and third layers, your rod should just barely penetrate into the layer underneath. Once it's full, strike off the top surface so it's perfectly flush with the cone and clear away any spilled concrete from the base plate. The next step requires a steady hand. Lift the cone straight up, vertically, and slowly. Do not twist, jerk, or tilt it because that will trigger a completely false reading. The concrete is going to slump down. Immediately grab your measuring scale. Place your rod horizontally across the empty cone and measure the vertical difference to the highest point of the slumped concrete. You're going to record this value to the nearest 5 millimeters. Section 5. Slump types and values. Once you lift the cone, there are 4 possible visual outcomes. A true slump settles evenly and retains a bit of the cone's original shape. That means you have reasonable cohesion. If one side just slips off, that's a shear slump. That indicates a harsh mix lacking cohesion, and you really should repeat the test. If it completely flattens out, that's a collapse slump. It's way too wet and carries a massive segregation risk. Finally, a zero slump means it hardly settles at all. It's extremely stiff and is going to be very hard to place. Now, I get asked this all the time. What is the perfect slump value? Well, there isn't one. Slump value is not universal.
The required slump depends entirely on your concrete grade, your placement method, how congested your reinforcement is, and whether or not you are pumping it. Always check your target slump against the approved project specification, the mix design, the QAP, and the specific method statement.
Section 6, Site Checklist and Takeaway. Before we get to the paperwork, I need to deliver the absolute ultimate site warning. Never add extra water at the site without explicit approval from the responsible engineer or the QA/QC authority. I see this happen too often. Unauthorized water completely destroys your carefully calculated water-cement ratio. It will cripple the strength, the durability, and the surface quality of your concrete. If the slump is low, follow the approved protocol. Do not just grab a water hose.
Finally, let's tie this all together. Look, a slump test is totally useless if it's not documented properly. Connect your measured result directly with your cube casting ID. Verify the RMC Shalon to make sure the dispatch time is within acceptable limits, update your concrete pour card immediately, and log the action in your daily progress report, the DPR. And remember, if the slump is outside the approved range, report it to QA/QC immediately. Don't just make a gut feeling decision. Follow the protocol.
To wrap up, verify your apparatus, fill in 3 layers with exactly 25 strokes, measure to the nearest 5 millimeters, and lock in your documentation. This workflow is an absolutely critical quality gate for your site. Now, to make sure you have all of this on hand, get the detailed Slump Test Workflow PDF from our Telegram channel. The link is right there in the YouTube description and in the pinned comment. Also, if you have any practical doubts from your own site experiences, comment below, and IBG InAI will reply. Think about this. If an RMC truck arrives on your site tomorrow, the mix looks perfect, but it fails the slump test, do you have the confidence to reject it? You should by IBG InAI Civil Workflows.